Here is why basically, or the importance of such course. Okay, why analog circuits? Well, basically because the devices that we learned so far, okay, like resistors, inductors, capacitors, are really short-handed. There are many applications that we can't, use such devices in them. Okay, there are many useful applications actually. The computer, for example, the things that we use every day, maybe for 10 hours or something, or maybe more. Okay, the cell phones that we use and use all the day. Okay, this is not just resistors, inductors, and the capacitors. There are many other stuff that adopted there so that you can have such cell phone with you. Okay, so basically, with such three devices that we learned so far, for example, in circuit theory, like resistor, inductor, and capacitor, we cannot make an amplifier. What's a signal amplifier? It's very, basic, very easy to understand, device. It's a device, or, how can I say this? Just a box like this, for example. This box here that contains some circuit. This circuit have some input voltage and gives you some output voltage. The input voltage is usually very small. You see it, very small one. And the output voltage here is an amplified version of the input voltage. It's exactly, it should be, ideally, perfectly, should be exactly the same as the input, but amplified. So for example, if instead of 0.01 volt at some point in time, it should be, for example, 5 volt, something like this. Okay? So you have here an input signal, you have the same signal as the output, but it's amplified. One such application that you see everywhere is a mic and the speaker of your computer that you are using like right now. So I have here my mic. Okay, this mic will will receive my voice. It will transfer it to an electrical signal, something like this one. Okay, and it also has this amplifier stuff. And this amplifier will amplify my voice, which is now an electrical signal, and send it to the speaker so you can hear me well. Okay, so this is basically one of the applications that we can't use just or only resistors, inductors, capacitor to make. What else? Electronic switch. So you guys know till this moment, the push button switch. So you have here in your home, you just make a switch like this or like this, then you can turn on and turn off the light. It's a manual, okay, mechanical switch. But there are some other switches that is electronically. I mean, you can control the flow of the current in some circuit, like this circuit, for example, based on a voltage, not manually. So it's also has a kind of switch, but this switch is electronic switch. It's not a mechanical switch. It's a electronic switch in the sense that you can control it using a voltage or a current. But by the way, this one can be made using inductors, and I think you studied this. You know the relay, right? So you can do that in using relay. That's good. But relays are very big, very big. For example, you can't have a relay inside your phone, right? Just imagine it. The relay is usually, that size, for example. So you can just have a relay in your phone. But we can do that, in, how can I say this? In nanometer, nanometer scale and put it in a circuit using, you know, the kind of devices that we're gonna learn in that course. Okay. So basically, if we're gonna explore more here, so if you send, for example, a voltage here equal to 0, this may be an open circuit. So this will be off. If you send another voltage, let's say, let's draw with another color. Let's say V is equal to 5. Okay, so some low and high voltage, something like this. Then it will be short circuit, and the current can flow, and this will be on. You can see the light. Okay, so you did this using a voltage. We're gonna also, you know, see this a lot in our course. What else? Another interesting application is AC-DC conversion. Just think about it. You know, many of our devices or appliances today are using DC voltage. Okay, one simple application is the phone. So the phone have a battery, and this battery is, you know, has a constant voltage, E, whatever it is, 3.65 volt, whatever, right? So there are many applications that use just, you know, constant voltage as input. Many applications. Okay, so but in nature we can generate AC voltage in a very easy way. So you have a problem here. What you can generate in nature, you know, like a power plant, for example, using gas or using, you know, whatever, you know, some, you know, some fuel, you can generate some electrical signal, but this electrical signal is usually AC. So we can generate easily AC or hydraulic turbine or whatever. So basically, in nature, we can generate AC voltages very easily, but we can't generate in an easy way a DC signal. Okay? And also handling AC signal is much easier than handling DC signals. That's another reason. So you can have this, but your application, some of your applications need this, some constant voltage. So here the voltage is changing versus time. Here is the voltage is constant versus time, right? So another device that we're gonna, you know, study a lot in this course is the AC to DC conversion. So one of the, you know, applications that you can't also do using resistor, inductor, capacitors, but you can do with other devices, which is we will discuss in this course, is how to generate DC out of AC. Okay, which is very interesting and very useful. Let's explore another two applications. There are many applications. Okay. Yes, digital camera. So, okay, so you know, guys, that the light, you know, this white light is actually composed of 7, you know, components or 7 other lights or colors, you know, red, violet, whatever, blue, yellow, you know, many of them, 7. Okay, and we need, you know, to take pictures, for example, you know, record a video or whatever. So we need, in principle, for this, we need some resistor, and that resistor can change its value, or sensor. Let's say sensor, not a resistor. Let's say sensor. We need a sensor, and that sensor can change its, you know, value or generate different output based on the incoming or the incident light color. So if the blue light came in, let's say it's an electrical device, let's say so. So here is a sensor circuit. It's a circuit. We're studying circuits in that course. okay, but with different devices. And here is the light, incident light. And here's some output. Of course, this is an electrical signal, so it should have something electrical. So the input is light, it's not electrical stuff, but the output is electrical. And VO here is proportional to, or have some relation, you know, with the incident light, with lambda. So this is a light color. So it have a relation, some kind of function that relates it to the incident light color. So for example, if the incident light is red, VO will be 1 volt. If the incident light is blue, then the output voltage will be, you know, 0.5 volt, something like this. Just for explanation, you know, it's not a real thing, but just for explanation. So based on that principle, we can do that. We can do that. We can have, you know, we can make a digital camera. We can see stuff, let's say it. Finally, and most importantly, computers. So based again on the devices that we're gonna learn in that course, other than inductors, capacitors, and resistors, we can do in principle, you know, the main components of a computer. Okay, how is that? So here is the computer that you have, or this is very old one. If you just open your case or open, you know, your laptop, you're gonna find many of this stuff, you know, very, you know, small, not very small, you know, like half a finger or something. Black stuff. It's called the chips. You're gonna find many of these. Okay. So what's these black chips is called integrated circuits. So that's what I was saying. Using the devices that we're gonna learn in that course, like transistors, diodes, or stuff, these can be fabricated in a very minimal scale, in nanoscale or micro scale. Okay, which is a huge advantage as well, rather than resistors and inductors, which is usually huge. Okay, so you can make a huge circuit inside one small chip like this. Each chip has what's called logic gates, like this one, for example. This is called the logic gate. And then each one of these logic gate contains a circuit like this. So at the end, we go to the circuit level. So, and this, by the way, this is a transistor that we're gonna, this is one of the transistors that we're gonna study in that course. So based on that transistors, we can make, let's go back now. Let's go in the reverse way. Based on the transistors that we're gonna learn in that course, we're gonna be able to make what's called the logic circuits. These logic circuits, you know, form what's called the logic gates. These logic gates, if you combine many logic gates together according to the application of the design, you can make a chip or integrated circuits. If you combine many integrated circuits and somehow in your design, you can make a computer. Okay, so we in that course we're gonna study that level, the circuit level, of course. That's not, you know, we're gonna look, we will not do a computer here, but we're gonna study, you know, the basic principles or the basic circuits that you can do to build a computer. Okay. Let's now go maybe to this is the last, you know, slide here. Okay, just give you a hint about what we're gonna do exactly, or how such elements or devices that we're gonna learn in that course do such applications. Okay, like for example, the amplification. So we're gonna learn amplification in details in that course, how to amplify a signal. Okay, this is amazing. This is the most basic, application of analog circuits, is to amplify signals. Okay, and these amplifiers are everywhere, everywhere. For example, when your phone receives a call, this call came in a form of wireless signal. This wireless signal, converted here in your phone into an electrical current and voltage. And the first, step afterwards is to amplify such a signal. And the last step before the sound goes to your headphone is to amplify again the signal. So you have multi-stage of amplification. That's why it's very important to study amplifiers. But how we can do that? We're gonna learn in that course many ways to do it, according to the device. So I said that there are many types of transistors. Okay, each one can amplify signals in its own way, but all can amplify signals. One of these ways is what we see here in this simple circuit here. Just imagine you have a resistor here called RB, okay, and another resistor R, and this R is or can be controlled by the input signal, the voltage input here. And the input here is the, the signal that we want to amplify. Okay. And here is the output. I forgot to draw it. Here is the output. So the output is just the voltage across the resistor R. So this is equal to VR, the voltage across R. And R magically can be controlled using the input signal that you want to amplify. Good. And we have here a battery, E, let's call it E. So the voltage at that point is E. As I said in the beginning, this course is solving circuits, but with other elements rather than capacitors, inductors, and resistors. We're going to add some more elements. Okay. So this is 0. This is a battery. So the battery, what a battery do? Make a voltage difference between its positive terminal and negative terminal. So it makes its positive terminal larger than in voltage than its negative terminal by the the value of the battery. The negative terminal is 0, so the positive terminal should be larger than 0 by E. So it have a value of E. So the voltage here is E at that point. Good. And those are series. Okay, and again, R can be controlled by V input, which is the voltage that we wanted to amplify. Good. So let's analyze this circuit here together. So VO, actually I wrote it here anyway. VO is equal to, this is the final answer. Just forget about it now. So VO is equal to E multiplied by R over R plus RB. Very simple voltage divider. I said that R can be controlled by the input. So let's assume that R equal to K, some constant, multiplied by the input. That's why we can control it. It has a function. It's a function of the input. Okay, good. So E, what is R? KV input. KV input. I just removed the R and put its value, which is KV input. If we assume that RB is much larger than KV input, which is that assumption here, what does that mean? That means that KV input plus RP approximately equal to RB. Just like 1 plus 0.01, you know, it's approximately equal to 1. So that's approximately equal to E K over RB V input. And let's look here now what we have got. So all that is just a constant, right? E is a battery constant, K is constant as well, RB is constant. If this constant is greater than 1, that means that we have an amplified version at the output of the input. So VO here, we discovered that VO is equal to some constant. Let's call it C multiplied by the input. If C is larger than 1, this is amplification. Right? So one of the transistors that we gonna study is basically, you know, have some, you know, very similar concept to this. This is just, you know, an ideal picture, of course, but, you know, one of the transistors have, you know, very similar concept. It's called the JFET. Okay. So that just, you know, to make the idea closer to your mind that we can do it. We just need, you know, some device that we can control its resistance. Other transistors do it in a various, you know, ways, but same concept at the end. Good. Let me also, you know, bring you. So I have simulate this to you just to see on MATLAB. Let me. You are not required to do these simulations or stuff. I'm gonna show you, you know, that we really amplify it. So here, so you know, this program just did what I have explained to you. Okay. So just to forget what's inside this program, just to see the output. Oh, yeah, it's in here. So look, guys. So if we assume the input is just a sine wave like this, which is the red one, look at the output. It's also sine wave, but it's amplified. Okay, it was in the beginning around, so the maximum here is, I think, 0.01, and now the maximum is 0.1. Look, 0.1. So we have the amplification is 10 times. Okay, you don't need, of course, to do this simulation or stuff. This is not, you know, but just to show you that we really work. It's just this circuit is really working. Okay, let's have another interesting application, which is, you know, the digital camera, or how to sense a light. Exactly the same principle, but this now it's not amplification, it's just sensing. So we said that we need a sensor, and that sensor can sense the light color. So, for example, in this video, this, you know, a dark green, the chair beside me is black, this is black, you know, the screen is white. So we need some, you know, sensors that says that, okay, in that location we have a white color, in that location we have a green color, in that location we have, you know, black, whatever. Okay, so that we need. Again, one of the devices that we're gonna study in that course is called the photodiode. Okay, and some special characteristics or some special devices of these photodiodes can do that. So basically, this is just, again, an ideal, you know, circuit. It's not exactly this way, but this is, you know, something to make it closer to your mind again. So imagine you have this sensor. This sensor has a resistor called R. This sensor now, we can say in similar to that way, it can be controlled by the input, but now it's controlled by the incident light. So the input here is light, you know, just a device here for this is a photodiode. So the light is coming in, you know, like this light here, and it will produce an output based on the incident light color or wavelengths. Okay, so each color in the, you know, of the 7 colors of the rainbow, we can say, each color has its own wavelength. Okay, so the resistance of the photodiode or this diode or this device, you know, will change based on the incident wavelength. For example, if for red, for example, the wavelength is lambda 1, you will have R1. If for blue, we have lambda 2, you will have R2. Okay? Again, what is the voltage at that point? It's E. And those are series. What is the VO here? VO again is equal to E R plus RP. So basically, if the incident light is lambda 1, which is red, we have VO1 equal to E R1 plus RB. If the incident light is blue, 2, E R2 plus RB, different output, right? So basically, your screen is something like this. So your screen, you know, is divided into what's called pixels, you know, just small squares. So that makes your screen, you know, and you have row of pixels and the column of pixels. And each pixel, you know, each square of those has its own color. Okay, so for example, the pixel that is just in front of this will be, you know, black. And, you know, based on the color, you will have, you know, a certain color in that pixel. So you can form a complete picture. Okay, how are we going to do this? Using, again, those special, you know, devices we're going to learn in that course. Okay, guys, so that's the end. This is just an introduction. Later, I will publish a recording for the rest of the you know, the real stuff, you know, the knowledge, you know, the devices, you know, and later again in this week, I'm going to publish the second lecture.